and all humans to the Unit 3 review of odd-numbered problems. It's important that you know that on Desmos, I have the solutions to exactly the problems that we're going over and the graphs written out and everything like that. And there'll be a link in this description of this video that will let you go straight there. So really you could just go straight there and get tons and tons of help. And you can also watch this video and get the same sort of help, but with my voice, which, as we all know, is what it is. So the first question says this stuff. You really haven't read any of these questions, so you should stop and then read before we even do this. Okay. First question talks about when this thing is happening and what percent is the student population changing each year. So it really says what percent is the student population changing each year. This year since 95 is completely irrelevant. That doesn't make any difference. All of the information that we need is found right here. We need to understand that this is a discrete interest problem. And discrete interest is written like this: 1 plus r over n to the nt. Memorize. Yeah, who knew, right? Got to know that. So in this case, 400 is our principal, and we have 1 plus, let's see, what is n? N is, okay, n is the time in years, and how much is it changing each year? That's not each month, that's how much it's changing each year, and that's what n represents. So 1 to the 1 times t. Well, the only thing left would be the rate, which would be this rate here. So that 0.12 is the interest rate, which is 12%. So this tells us right here it's 12%. Again, I'm just going over odd number problems. This is the correct solution. Number 3. What a fun problem. This makes us recall our exponent rules. Who knew that we would ever use them, even though we use them every single day, right? Who knew? And just writing them down again for the 50th time, because those are our rules. And that's what's going to determine our solution to this problem. In other words, I've got to combine this stuff, so I just have one base. On each side, one base. That's it. So in other words, 7. So 7 to the a times 7 to the b, 7 to the a times 7 to the b, equals, yes, 7 to the a plus b, 7 to the c over 7 to the d, 7 to the c over 7 to the d equals, yes, that's right. I'm waiting. What is it? Okay, 7c minus d. At this point, what can we do? Take the log, say 7 on both sides. Bye. That's why we had to get one base so we could cancel those out. So we get a plus b equals c minus d, and we solve for d. Wait, this is the answer, right? No? Why is this not the answer? I solved for d, right? No, you did not. You solved for negative d. So I'm going to change all of the signs, or add this over here, subtract that over here, and I'll get that d equals, come on, think about it, what does d equal? That's right, negative a minus b plus c. Good. Which one does that look like? Well, not these. I agree, not those. Yep, nothing's being multiplied, I agree. So B or C? Nope, A is not negative. I mean, A is not positive, so it's not this one. There it is. Done. Not talking about that. Just moving on. Read 5. You haven't read it yet. Read 5. Read it. Great, so then what equation do I need to know? Yes, this equation. That's the equation I have to know to be able to do this. What is each part? You better go back and watch the video then if you don't know. Right, so it asks for the asymptote. The asymptote is determined by k. I can literally just cover my finger up and get f of x equals to k. F of x is an x value? Yes, you're right, it's not. It is a y value. It's like saying y equals k. So for exponentials meaning something to a power, it's an exponential. The asymptote is y equal to k. So what's the k here? That's right, it's a -4. So there it is, done. Let's keep going. 7. This stuff, read it. Right, we need to know our rules. This is the rule I need to know. So it's log of something minus log of something is log of that thing over that thing. It's our division rule. Or subtraction to division, or division to subtraction. I've got to combine this. I can't do anything before I combine that. There's nothing I can cancel. I cannot just write 10 here and 10 here and cross them off. That's just totally wrong. Okay, so let's use this rule now and write it out for me. Stop the video, write out that rule. Okay, you have not written it out. I promise you that, so write it out. What do you think it would become using this thing? Pause it and try again. Look at that, you can say family forever. Which we're not, unless you actually write this down. Okay, good. That is what it comes out to be. What's the next step? That's right, that recalls that I have to know that if it doesn't say anything there, it means that it's log base 10. So I can just write that there, and that'll help me know. So how do I cancel this stuff out? Yes, by writing a 10 here. That cancels this out. Do I have to do it to both sides? Absolutely I do. I have to do it to both sides. Where should I put the 10? Here, 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 here. Don't even think about it. Where did you put it over here? Yeah, the bottom left. So the bottom left. Good. There it is. So that means we have x plus 3 over x minus 1 equals, wait, what does this mean? Yeah, 10 to the 1. 10 to the 1. 10 to the 1 is 10. That's right. What do I do next? Well, yeah, I've got that awkward thing on the bottom. Got to get rid of it. Multiply both sides by x minus 1. Goodbye. What do I do here? Distribute. So, Furman, did you distribute? Andrew, did you distribute? Anthony, did you distribute? Adriana, did you distribute? Did you? Okay, there it is. Now just solve for x. When you solve for x, you'll get... Yep, I'm not doing this. You've got to do this work. 3, 2, 1, that's right. 13 over 9. We're on 9 now. Read 9. Actually, read 9. So we've got 3 expressions. We need to find out if they're the same as this thing. How do I do that? Well, I have to see if I can rewrite this thing to look like any of those. What's the first thing that I notice that I can do with this stuff here? Well, the first thing, whether I notice it or not, is that I should always bring that inside first, right? So I'm going to un-p the log. I'm unpaying the log. Yeah, that's the way we say it these days. So in other words, this thing can be written as ln of 2 times x cubed to the what power? Yes, to the 4th power. What's the next thing to do? The next thing to do is to use our power rule that says x to the a to the b power is x to the ab. In other words, this stuff is getting raised to the 4th power. So I've got to multiply the exponents. In this case, there's no exponent, so that means it's exponent of 1. So I've got natural log 2 to the 1 times x cubed to the 4th power. That would become natural log of 2 to the, yeah, do the work. 2 to the what power? What's 1 times 4? 4. X to the, what's 4 times 3? Yeah, 12. Okay. Nothing more that I can do here. Now I can look at this and see if it matches any of these statements. Okay, like, clearly I have no idea if it matches this one or this one, but this looks pretty close to here, right? What's the difference? Yeah, the difference is this one doesn't have a 4. Is there like a 4 somewhere else? Is there a 4 there or here? No, there's not. So there's nowhere to fix that. This one, these two should look exactly the same, and they don't. That means that this one isn't correct, because it doesn't have 2 to the 4th. Right. Good, I'm glad you're thinking about that. That means that we should cross up D and B, because those couldn't possibly be solutions. Now let's see what can we do next. We've already been working with these rules. When I have multiplication inside the lockdown box, what does that equal outside of it? I'm waiting. What does this equal? Yes, that equals addition outside of the box. So that means ln of 2 to the 4th plus ln of x 12. Look good so far? It does to me. So this thing looks awfully close to something. Which one? Does it look like 1 or 3? Looks weird to you. Okay, that's fine. I know it looks weird to you. Get over it. It doesn't look like this one. It looks like this one. What's the difference here? There's an ln x12. This one says ln 16. This one says ln 2 to the 4th. Are they the same? Are they? What's 2 to the 4th? 2 times 2 is 4, times 2 is 8, times 2 is 16. Which means, yes, they're exactly the same. So 1 is good. That means I can cross off which one? That's right, because this one doesn't include 1. Alright, so that's that one. And this one looks like I just peed in front of the log, right? So let's go back to this one right here. ln 2 to the 4th plus ln x12. And let's just do that. Use the p rule, the power rule. There's the power rule. What do? Sophia, what do? Bianca, either one of you. What do? Right. Move this in front, move that in front. I get 4 natural log of 2 plus 12 natural log of x. Does that look like it? 12 natural log of x, 4 natural log of 2. It does. So I can choose answer choice C, 1, answer choice C, 1 and 3. Read number 11. Read it. If this equals this, and this equals this, then this equals what? Well, regardless of all of this stuff, stop thinking, stop doing anything, and actually read the problem. Okay. Regardless of this stuff, we know that this thing, by our rule, by our log rule, says that this has to equal this. That's what our rule says. That's what we know. Now let's go back and look at this stuff. It says log base b of x equals p. Well, that's this thing. It says that this equals p. It says that this equals, this whole thing equals that thing. So p plus q, done. Use Desmos to help you with the rest of the problems, and good luck with everything. I'll most likely post part 2 of this, but enjoy part 1, and good luck.